So let's dive into modern data warehousing. A data warehouse is a place where we store a large portion of our data in a relatively easily accessible environment and format for analysts and others to use. Often it's storing data from a variety of sources or databases. This data is for analysis, online analytical processing, and reporting. The important fact is that a transactional database doesn't lend itself well to analytics. To effectively perform analytics, you need a data warehouse. Data warehouses have to handle big data. Now, big data is a general description of data which meets the 5 V's: velocity, volume, value, variety, and veracity. It's just collecting a lot of data from various sources, aggregating it, and then trying to glean business intelligence insights from it. There are some public data sets available, but in most cases, each company collects their own data to use. A modern data warehouse might contain a mixture of relational and non-relational data. So this can be made up of things such as image files, video streams, and IoT sensor data such as traffic counting devices. So this is a modern data warehouse. Modern data warehouses now need to offer services that support these new sources of data. Some of these include Azure Data Factory, Azure Data Lake Storage, and Azure Databricks. We can also use tools such as Power BI to analyze and visualize the data, generate reports, charts, and dashboards. Modern data warehousing usually combines batch processing and stream processing, so that typical large-scale business will need some combination of historical data, which is associated with batch processing, and real-time, up-to-date data, which requires stream processing. This means that the modern data warehouses will incorporate both batch and stream processing. In batch processing, we wait for a certain amount of raw data to pile up before running an ETL job. Typically, this means data is between an hour to a few days old before it's made available for analysis. Batch ETL jobs will typically be run on a set schedule, say every 24 hours, for example, or in some cases once the amount of data reaches a specific threshold. By definition, batch processing entails latencies between the time data appears in the storage layer and the time it is available in analytics or reporting tools. However, this is not an issue for historical data, and this type of data is often generated by batch processes at regular intervals based on the live sales data that may be captured continuously. Stream processing is used to query continuous data streams and detect conditions quickly within a small time period from the time of receiving that specific data. The detection time period varies from a few milliseconds to minutes. It's also called by many names such as real-time analytics, streaming analytics, complex event processing, real-time streaming analytics, and event processing. There are a lot of streaming data available, such as customer transactions, activities, website visits, and they'll grow more faster with all the use of IoT devices that's happening all over the world now. Streaming is a much more natural model to think about and program these IoT devices, and these IoT devices are becoming very prevalent. When it comes to modern data warehouse design, an organization's long-term business strategy should be just as important as the current business and technical requirements. User analysis and reporting requirements must be identified, as well as hardware, development, testing, implementation, and user training. In light of the mission-critical nature of the data warehouse, it's necessary to optimize the design for maximum performance. One major step involved in optimizing your performance is to first identify the type of workload we plan to execute in our data warehouse. In 2007, the Gartner Group identified 6 distinct workload types that are commonly used in data warehouses. The first of this would be continuous data loading. So this workload creates an environment that's very similar to OLTP, or online transactional processing, because indexes and other optimization structures have to be continuously updated. This can have a very big effect on summary and aggregate data which is used to support dashboards and pre-built reports. It can also be used for batch data loading. So some of your data that's not needed in real time is very good for batch data loading. Warehouses that support reporting systems and large numbers of standard pre-built reports, which require indexing and tuning for specific SQL queries. New types of storage partitioning may need to be created, and other types of optimization structures in the data warehouse for data warehouses that are used exclusively as reporting systems. We can use it for business analytics, so tactical business analytics, right? So in which business professionals with little or no programming experience use these analytical applications to drill down and drill through multi-dimension objects. The use of true ad hoc queries, so data miners, people who use the data in random, unpredictable ways, making it impossible to optimize and tune their queries. And finally, another workload would be analytic and BI-oriented functions. So we want to make a lot of analysis, and we want to do some business intelligence work with our data. Let's discuss some data warehouse uses. So the traditional data warehouse. In a typical IT environment, traditional data warehouses ingest, model, and store data through an ETL. These ETL jobs are used to move large amounts of data in a batch-oriented manner and are most commonly scheduled to run daily. Running these jobs daily means that at best, the warehouse data is a few hours old, but more typically it is a day or older. Because ETL jobs consume significant CPU, memory, disk space, and network bandwidth, it's difficult to justify running these jobs more than once a day. In a time when application programming interfaces, or APIs, were not as prevalent as they are now, ETL tools were the go-to solution for operational use cases. It can also be used as a data mart. So data mart is focused on a single functional area of an organization and contains a subset of data stored in a data warehouse. The data mart is a condensed version of a data warehouse and is designed for use by a specific department, unit, or a specific set of users in the organization. Data marts usually draw data from only a few sources compared to a data warehouse. Data marts are small in size and are more flexible. The real-time data warehouse. The real-time data warehouse describes a system that reflects the state of the warehouse in real time. So if a query is run against that real-time data warehouse to understand, say, a particular facet about the business or entity, that answer reflects the state of that entity at the time the query was run. So the data is always up to date. Most data warehouses have data that are highly latent, right, or reflects the business at a point in the past. A real-time data warehouse has low latency data and provides current real-time data. The historical data warehouse. So in the past couple of decades, the government has kind of mandated how long we have to keep our data and our historical information. These mandates have caused an increase in the popularity of the historical data warehouse. This type of data warehouse contains data volumes that are many times larger than that of traditional data warehouses, which requires you to pay close attention to storage structures and partitioning. Data refreshes are semi-frequent, say weekly or even monthly, and there's usually less query traffic than with traditional data warehouses, data marts, or real-time data warehouses. And finally, the analytic OLTP. So an analytic OLTP warehouse is one that has been created to be all things to all people. So in the old days when hardware cost more than a programmer's time, one database was used for both rapid transactional data and resource-intensive analytical queries. Mixing these two workloads always slowed the applications down and made them non-responsive. This architecture always has been and always will be a worst practice scenario because it's not scalable or extendable. Data warehouse performance issues. One of the performance issues that we may encounter is due to mixed workload. So the common one-size-fits-all paradigm isolates transactional and analytical workloads into separate specialized database systems. Operational data is periodically replicated to a data warehouse for analytics. And due to the competitiveness of enterprises today, we need real-time reporting on operational data. So the database needs to provide performance guarantees for transactional workloads and at the same time efficiently evaluate complex analytical queries. Optimizing for these various and contradictory requirements might not be possible. If you can't split the workload into separate data warehouses or data marts, you might have to settle for good enough or less. You need to be aware of what types of workloads your data warehouse is supporting. As a direct result of the need for real-time data loading and automated transactions, your best data source might be one or more transactional databases and not your data warehouse. Why do you need a data warehouse? The concept of a data warehouse is not too difficult to understand. Basically, we need to create a permanent storage space for the data needed to support reporting, analysis, and other business intelligence functions. By providing data from all these different sources, managers and executives will no longer need to make business decisions based on limited data or old data. In addition, data warehouses and related business intelligence can be applied directly to business processes, such things like market segmentation, inventory management, and financial management and sales. A data warehouse also stores large amounts of historical data so we can analyze different time periods and trends in order to make future predictions. Such data typically can't be stored in a transactional database or used to generate reports from a transactional system. Benefits of data warehousing. So once a data warehouse is in place and populated with data, it'll become part of a business intelligence solution that will deliver benefits to business users in many ways. One of these is end user creation of reports. So end users can now create their own reports in a business intelligence environment. They can create more useful reports because of the power and capability of these new tools. And moving the creation of reports to a BI system increases consistency and accuracy, which goes hand in hand with reducing cost. Ad hoc reporting and analysis. So since the data warehouse eliminates the need for BI tools to compete with the transactional source systems, users can now analyze data faster and generate reports more easily. They can slice and dice in ways they never could before. They can use data mining and find patterns in data that we would normally never be able to see. We have dynamic presentation through dashboard. So managers want to see everything right away. They want all their data up to date and visible in one spot. This is accomplished via dashboards. These are sophisticated displays that show information in creative and highly graphical, easy to understand forms. And we have drill down capacity. So users can drill down into the details underlying the summaries on dashboards and reports. So if they see something on the dashboard that they want to investigate further, they can click it, drill down, and get more of a fine-grained look at the data. And finally, support for regulations. So some regulations have requirements that transactional systems are sometimes not able to support. With a data warehouse, the necessary data can be retained as long as the law requires. More benefits of data warehousing. Metadata creation. So descriptions of the data can be stored with the data warehouse, so it makes it easier for users to understand what the data is actually trying to tell you. This will make report creation a lot simpler for the end user. We have support for operational processes. So data warehouses can help support our business needs, such as the ability to consolidate financial results within a complex company that uses different software for different divisions. And data mining. So it kind of goes hand in hand with those ad hoc queries, but you also have the ability now to help find hidden patterns using automatic methodologies and algorithms. So while reporting tools can tell you where you have been, data mining tools can tell you where you're going. We have security. So data warehouse makes it much easier to provide secure access to those who have a legitimate need to the specific data. So we don't have data in multiple sources. We don't have to worry about the security of multiple sources. Now we just worry about the security of our data warehouse. And finally, analytical tool support. So there are vendors who have analytical tools Tableau is one of those that allow business units to slice and dice the data and create reports and dashboards. These tools will work best when extracting data from a data warehouse. Let's look at some of the modern data warehouse architecture. A modern data warehouse lets us bring all of our data together at any scale and to get insights through analytical dashboards, operational reports, or advanced analytics for all your users. We're going to combine all our structured and unstructured data using Azure Data Factory to Azure Blob Storage. Once it's in Azure Blob Storage, we'll leverage that data to perform scalable analytics with Azure Databricks and achieve cleansed and transformed data. Once we have that cleansed and transformed data, we can move it to Azure Synapse Analytics to combine with existing structural data, and now we've created one repository for all of our data. We can leverage native connectors between Azure Databricks and Azure Synapse Analytics to access and move data at scale. We build operational reports and analytical dashboards on top of Azure Data Warehouse to derive insights from the data and use Azure Analysis Services to serve thousands of our end users. We can also run ad hoc queries directly on data within Azure Databricks. So let's take a look at some of this architecture in detail. Azure Synapse Analytics. Azure Synapse Analytics is a fast, flexible, and trusted cloud data warehouse that lets us scale not only our compute, but also our data store. We can scale them elastically and independently of each other. So we can scale up our compute services and leave our data store size alone, or we can scale them both up. We can scale them both down. If we notice that we're not using as much storage, we can scale it down and leave compute where it is. So again, independently with a massively parallel processing architecture. So Synapse SQL leverages a scale-out architecture to distribute computational processing and data across multiple nodes. Compute is separate from storage, which enables you to scale compute, again, independently of the data in your system. For dedicated SQL pool, the unit of scale is an abstraction of compute power and is also known as a data warehouse unit. For serverless SQL pool, since it's serverless, scaling is done automatically to accommodate query resource requirements. Synapse SQL uses a node-based architecture. Applications connect and issue transactional SQL commands to a control node, which is a single point of entry for Synapse SQL. With decoupled storage and compute, when using Synapse SQL, one can benefit from independent sizing of computational power, irrespective of your storage need. For serverless SQL pool, scaling again is done automatically, while for a dedicated SQL, you can grow or shrink your compute power, you can pause compute capacity, or you can resume compute capacity during operational hours. Azure Data Factory. So Azure Data Factory is a hybrid data integration service that allows us to create, schedule, and orchestrate our E2L or ELT workflow. So we create our workflows, we schedule our workflows, and then we orchestrate them. So it all depends. Do we want to run this multiple times a day? Do we want to run this workflow once a day? And with Azure Data Factory, you have that ability and flexibility to schedule it the way it works for you and your corporation. Azure Blob Storage is a massively scalable object storage, and it's great for any type of unstructured data. This could be images, videos, audios, and documents. Blob Storage is designed for serving images or documents directly to the browser. We could be storing files for distributed access. We could be streaming audio and video, writing the log files. Again, it's unstructured data and it's object storage. So it's great for anything that doesn't quite have the same structure over and over. Azure Databricks. Azure Databricks is a fast, easy, and collaborative Apache Spark-based analytics platform. Azure Databricks is a data analytics platform optimized for the Azure Cloud Services platform. Azure Databricks offers us two environments: the Azure Databricks SQL Analytics and an Azure Databricks Workspace. So further in this course, we're going to investigate Databricks into more detail, and we'll see what both of those environments have to offer, the similarities and the differences between them. So Azure Analysis Service is an enterprise-grade analytics as a service that lets you govern, deploy, test, and deliver your business intelligence solution with confidence. So it supports cloud and on-premise data sources. It's an enterprise-grade semantic data model, and it adds support for ad hoc data analysis. Power BI, or Power Business Intelligence. This is a suite of business analytic tools that deliver insights throughout your organization. So you can connect to hundreds of data sources, you can simplify your data preparation needs, and you can drive ad hoc analysis. Create beautiful reports, publish them for your organization and the executives in your organization, put them on the web, spread them out through your mobile devices. Right? With Power BI, opportunities are pretty much endless. Now I'm going to introduce Azure Data Factory. So what is Azure Data Factory? Azure Data Factory is a fully managed data migration and integration service that enables Microsoft Azure users to bring together data from a variety of sources in the Azure public cloud. The Azure Data Factory service allows users to integrate both on-premise data in Microsoft SQL Server, as well as cloud data in Azure SQL Database, Azure Blob Storage, and Azure Table Storage. Once Azure Data Factory collects relevant data, it can be processed by tools like Azure HDInsight. Azure acts as a service that can orchestrate and operationalize processes to refine these enormous stores of raw data into actionable business insights. Azure Data Factory is a managed cloud service that's built for hybrid extract, transform, and load jobs, extract, load, and transform jobs, and data integration projects. So how does Azure Data Factory work? Azure Data Factory contains a series of interconnected systems that automate and orchestrate the entire data integration process from end to end, so that users have a single pane of glass into their ETL data pipelines. Enterprises have huge amounts of data from a variety of sources. These sources may be on-premise data located at your physical site on your physical servers, data in the cloud, structured data sources such as SQL databases, Excel spreadsheets, and OLTP systems, unstructured data sources such as NoSQL databases, and semi-structured data sources such as XML and email. After we have the data collected and available in the centralized data store, we need to process or transform the collected data by using ADF mapping data flows. Data flow is a feature of Azure Data Factory that allows you to develop graphical data transformation logic that can be executed as activities within ADF pipelines. The intent of ADF data flows is to provide a visual experience with no coding required. If you prefer to code transformations by hand, ADF supports external activities for executing your transformations on compute services such as HDInsight Hadoop and Spark. HDInsight is a fully managed, full-spectrum open-source analytics service for enterprises that allows you to use open-source frameworks such as HDInsight and Spark. We can also use our data in Data Lake Analytics. So Azure Data Lake Analytics is a fully serverless service, which means we don't need to create any infrastructure instances or clusters to use it. You just need to be able to submit jobs that are executed on your massive amounts of data in a parallel processing fashion. And finally, we can use our data for machine learning. We could take all the data we collected to train a machine learning model, say, to predict future trends for our business. Azure Data Factory built-in support. So Azure Data Factory has built-in support for pipeline monitoring. We want to see what's happening inside of our pipeline. First of these is Azure Monitor. So Azure Monitoring Tool is the application for consolidated monitoring, application visibility, and enhanced security. We can also use Azure API, so we can send API calls to check the status of our data pipeline. We can do much the same with Azure PowerShell. We can use the Azure Monitor logs for pipeline monitoring support to get a really good insight on everything that's happening. And we can use the Azure Portal Health panels, which will give us a graphical user interface and to be able to see the health of our data pipelines all in one consolidated dashboard. Azure Data Factory key components. So your Azure subscription may have one or more Data Factory instances attached to it. So what are some of the key components? First one of these would be activities. So they represent a processing step in a pipeline. So you may want to use, say, a copy activity to copy data from one data store to another data store. We also have data flows. So you can create and manage graphs of data transformation logic that you can use to transform any size data. You can build up a reusable library of data transformation routines and execute these processes in a scaled out manner from your ADF pipeline. Another component of the Azure Data Factory are data sets. So data sets represent data structures within the data stores. So they simply just point to or reference the data you want to use in your activities as inputs or outputs. Next, we have integration runtimes. So the integration runtime is the compute infrastructure used by Azure Data Factory to provide data integration capabilities across different network environments. One of these would be data movement. So copy data across data stores in public networks and data stores in private networks, for example. We also have linked services. Linked services are much like connection strings, which define the connection information that's needed for Data Factory to connect to many of its external resources. Think of it this way: a linked service defines the connection to the data source, and a data set represents the structure of the data. So for example, an Azure Storage linked service specifies a connection string to connect to the Azure Storage account. Additionally, an Azure Blob dataset specifies the Blob container and the folder that contains the data. And finally, we have pipelines. So a data factory might have one or more pipelines. A pipeline, we hear it a lot. A pipeline is a logical grouping of activities that performs a unit of work. So together, the activities in a pipeline perform a task. One of these could be, for example, a pipeline can contain a group of activities that brings in data from an Azure Blob, then runs a Hive query on an HDInsight cluster to partition the data. The benefit of this is that the pipeline allows you to manage the activities as a whole, right, as a group, instead of managing each one individually. The activities in a pipeline can be chained together to operate sequentially, or they can operate independently in parallel. Now let's discuss Azure Data Lake Storage Generation 2. Azure Data Lake Storage Gen 2 is Microsoft's latest version of cloud-based big data storage. Data Lake Storage Gen 2 builds on Blob storage and enhances performance, management, and security. It enhances performance because performance is optimized. We don't need to copy or transfer data as a prerequisite for analysis. Compared to the flat namespace on Blob storage, the hierarchical namespace greatly improves the performance of directory management operations, which improves overall job performance. Management is easier because you can organize and manipulate files through directories and subdirectories, and security is enforceable because you can define POSIX permissions on directories or individual files. Features of the Data Lake Storage. First of all, it's cost effective, so it offers low cost storage capacity and transactions. It has Hadoop compatible access, so it allows you to manage and access data just as you would with a Hadoop distributed file system. It has an optimized driver, so the ABFS driver is optimized specifically for big data analytics. The corresponding REST APIs are surfaced through an endpoint, and it has a superset of POSIX permissions. So the security model for Data Lake Gen 2 supports ACL and POSIX permissions along with some extra granularity specific to Data Lake Storage 2 settings. One big feature of the Azure Data Lake is scalability. Azure Storage is scalable by design, whether we use Data Lake Storage Gen 2 or Blob storage interfaces. It's able to store and serve many exabytes of data. This amount of storage is available with throughput measured in gigabytes per second at high levels of input-output operations per second. Processing is executed at near constant per request latencies that are measured at the service, account, and file levels. Another feature of Azure Data Lake is cost effectiveness. Because Data Lake Storage Gen 2 is built on top of Azure Blob storage, storage capacity and transaction costs are lower. Azure Data Lake is a cost-effective solution to run big data workloads. You can choose between on-demand clusters or pay-per-job model when data is processed. And unlike other cloud storage services, you don't have to move or transform your data before you can analyze it. And additionally, features such as the hierarchical namespace significantly improve the overall performance of your analytic jobs. This improvement in performance means that you require less computational power, and as a result, your price goes down. So they're directly related to one another. Azure Data Lake Entities. So because Data Lake Storage Gen 2 is built on top of Azure Blob Storage, multiple concepts can describe the same things. So the following are the equivalent entities as described by different concepts. So first, a concept. So with Blob Storage, the concept is just a general purpose object storage. With Azure Data Lake Storage Gen 2, the concept is analytics storage. Top-level organization with Blob Storage would be a container, and it will also be a container for Azure Data Lake Gen 2. Next, we have lower-level organizations. So for Blob Storage, this could be a virtual directory. When we're talking about Data Lake Generation 2, this would also be just a plain directory. It wouldn't be a virtual directory, it would be a directory itself. And finally, data containers. So a data container with Blob Storage would be a blob. Data container in Azure Data Lake Gen 2 would be considered a file. So it's just interchangeable terms depending on whether we're using blobs or Data Lake Storage Gen 2. So let's look at some of the supported blob storage features. Blob storage features such as diagnostic logging, access tiers, and lifecycle management are available to your account. We also have the Azure service integration. So Data Lake Storage Gen 2 supports several Azure services. You can use them to input data, perform your analytics, or create some visual representations. And we also have support for open source platforms. So several open source platforms support Data Lake Storage Gen 2. Some of these would be Hadoop and Spark, as we previously mentioned. Now let's discuss the Azure Databricks environment. So what is Azure Databricks? Databricks is an industry-leading cloud-based data engineering tool used for processing and transforming massive quantities of data, and also exploring that data through machine learning models. So we have the Azure Databricks SQL Analytics. This provides an easy-to-use platform for analysts who want to run SQL queries on their data lake, create multiple visualization types, graphs, and charts to explore their query results from different perspectives, and to build and share dashboards. We also have Azure Databricks Workspace. This provides an interactive workspace that enables collaboration between your data engineers, your data scientists, and machine learning engineers. For a big data pipeline, the data is ingested into Azure through Data Factory in batches or streamed near real time. This data lands in a data lake for long-term persistent storage in Azure Blob Storage or Azure Data Lake Storage. As part of our analytics workflow, we'll use Azure Databricks to read data from multiple data sources and turn it into breakthrough insights using Spark. So what is Azure Databricks SQL Analytics? As mentioned before, Databricks SQL Analytics allows us to run quick ad hoc SQL queries on our data lake. They support multiple visualization types to help us explore our query results from different perspectives. Databricks also has features like alerts to help us monitor and integrate, so it can notify us when a field returned by a query meets a threshold. It also allows dashboards, so it lets us combine visualizations and text to share insights from our queries, and SQL endpoints, So SQL queries run on a fully managed SQL endpoint sized according to query latency and the number of concurrent users. Enterprise-grade Azure security. Azure Databricks SQL Analytics provides enterprise-grade Azure security, including Azure Active Directory integration, role-based controls, and service-level agreements that protect your data and your business. So we can integrate with Azure Active Directory. That'll enable us to run complete Azure-based solutions using the Azure Databricks SQL Analytics. Role-based access gives us that fine-grained user permissions for alerts, dashboards, SQL endpoints, queries, and data. And that enterprise-grade SLA will be used to protect our data and to protect our business. It's important to know that Databricks SQL Analytics is a Microsoft Azure first-party service that's deployed on the global Azure public cloud infrastructure. So all communications between components of the service remain within the Azure network backbone, so it doesn't traverse the public internet. And that's important to know, especially when it comes to security and your data. Azure Databricks Workspace. So the Workspace is an analytics platform based on Apache Spark. Azure Databricks Workspace is integrated with Azure to provide one-click setup, streamlined workflows, and an interactive workspace that enables collaboration between, again, our data engineers, our data scientists, and our machine learning engineers. For our big data pipeline, that data is brought into Azure using the data factory in batches or again streamed in real time. The data lands into a data lake, and then as part of our analytics workflow, we use Databricks to read data from multiple data sources and then turn it into breakthrough insights using Spark in the Databricks Workspace. And the Apache Spark Analytics Platform. So the Azure Databricks Workspace comprises the complete open source Apache Spark cluster technologies and capabilities. Spark in Azure Databricks Workspace includes MLIB, or Machine Learning Library, consisting of common learning algorithms and utilities. We could do things like classification, regression, and clustering. It also has GraphX, so that graphs and graph computation for a broad scope of use cases from anything from cognitive analytics to data exploration. It offers the Spark Core API. So that API includes support for SQL, Python, and Java. And it gives us Spark SQL and data frames. So Spark SQL is a Spark module for working with structured data. A data frame is a distributed collection of data organized into named columns. Think of an Excel spreadsheet. It's conceptually equivalent to a table in a relational database or a data frame in R or Python. And finally, streaming. We can perform real-time data processing and analysis for analytical and interactive applications. So that integrates with HDFS, Flume, and Kafka. The Azure Databricks Workspace builds on the capabilities of Spark by providing a zero management cloud platform that includes a platform for powering your favorite Spark applications. It provides us with fully managed Spark clusters, and fully managed means we don't have to worry about the underlying infrastructure, and an interactive workspace for exploration, visualization, and collaboration. Let's look at Apache Spark clusters in the cloud. So Apache Spark is an open source unified analytics engine for large-scale data processing. Spark provides an interface for programming entire clusters with implicit data parallelism and fault tolerance. Azure Databricks has a secure and reliable production environment in the cloud, and we could do things such as create clusters really quickly in seconds. We can auto-scale. So that means that we can dynamically auto-scale our clusters up and down and share them across teams based on capacity, based on our usage. We can take advantage of REST APIs and use clusters programmatically by invoking these REST APIs. We can use secure data integration capabilities that are built on top of Spark that enables us to unify our data without centralization. And finally, we have instant access to the latest features with each new Apache Spark release. The Azure Databricks Runtime. So the Azure Databricks Runtime is built on top of Apache Spark and is natively built for the Azure Data Cloud. The Azure Databricks Runtime. The Azure Databricks Runtime is built on top of Apache Spark and is natively built for the Azure Data Cloud. Azure Databricks completely abstracts out the infrastructure complexity, so you don't have to worry about it. You don't need specialized experts to create it. For data engineers who care about the performance of production jobs, Azure provides a Spark engine. This Spark engine is fast and performs very well through various optimizations at the I/O layer and the processing layer. The Azure Databricks collaborative environment. So the workspace for collaboration is very important. Through a collaboration and integrated environment, Azure Databricks streamlines the process of data exploration, prototyping, and running data-driven applications in Spark. So we can determine how to use our data with this easy data exploration. We can document that process in Notebook. We can visualize the data in a few clicks and use our familiar tools like Matplotlib. We can use these interactive dashboards to create dynamic reports, and we can use Spark and interact with the data simultaneously. The Azure Databricks Enterprise Security. So the Databricks Workspace provides enterprise-grade Azure security using a lot of the Azure-based solutions like Azure Active Directory integration. So we can run a complete Azure-based solution using Databricks. We also have enterprise-grade SLAs and role-based access control if we want a little more fine-grained user permissions for things like Notebook, clusters, jobs, and data. Now let's dive into Azure Analysis Services. Azure Analysis Services is a fully managed platform as a service that provides enterprise-grade data models in the cloud. The data model provides an easier and faster way for users to perform ad hoc data analysis using tools like Power BI and Microsoft Excel. We can also use some advanced features to combine data from multiple sources, define our metrics, and secure our data in a single, trusted tabular semantic data model. Azure Analysis Service integrates with many Azure services, enabling us to build sophisticated analytic solutions directly in the Azure cloud. One of these things that we can integrate with is Azure Active Directory. It provides secure, role-based access to our critical data. We can integrate with Azure Data Factory. We can use those pipelines by including an activity that loads data into the model. And with Azure Automation and Azure Functions, we can use those for lightweight orchestration of models using custom code. Azure Analysis Service Tiers. We have 3 service tiers. We have the Developer Service Tier, the Basic Service Tier, and the Standard Service Tier. The Developer Service Tier is recommended for evaluation and development and testing. Right, so a single plan includes the same functionality of the Standard Tier, but is limited in processing power, QPUs or query processing unit, and memory size, because remember, every plan has QPUs and memory size. And when we create a server, we select a plan within a tier. We can always move up a tier, but we can't go back, so we can't downgrade to a lower tier from a higher tier. The basic tier is good for production solutions with smaller tabular models, a lot less user concurrency, and simple data refresh requirements. It doesn't support the scale out features, so as a result, anything mission critical should be in the standard tier. This is a mission critical production applications that require elastic user concurrency, have rapidly growing data models. So it supports advanced data refresh for near real-time data model updates and supports all tabular modeling features. So you have to know which tier is right for you and when it is right for you. Azure Analysis Service. So one of the big things is scaling, and it scales to our needs. It allows us to scale up or scale down. It allows us to pause our server or resume the server. We can also scale out resources for fast query response. So with scale out, client queries are distributed amongst multiple query replicas in a query pool. Query replicas have synchronized copies of your tabular model. This provides us with very fast query responses. And availability by region is another thing we have to keep in mind. Azure Analysis Services is supported in regions throughout the world. Supported plans and query replica availability depend on the region that you choose. So it's something you should investigate and look into before you start your journey into analysis services. Azure Analysis Services is compatible with many of the great features already in SQL Server. In fact, it was built upon SQL Server Analysis Services. It supports tabular models. It allows us for partitioning. So partitioning enables incremental loads, increases parallelization, and reduces a lot of our memory consumption. It takes advantage of direct query mode. So that leverages the back-end relational database for storage and query execution. And we can handle extremely large data sets. These data sets could be in SQL Server Data Warehouse, an Azure SQL database, Synapse Analytics, Oracle, right? But we can handle massive amounts of raw data in these systems. So how do we secure our Azure Analysis Services? Built in right away with Azure, you get security from distributed denial of service or DDoS attacks. Azure Analysis Service provides security for our sensitive data at multiple levels, and as I mentioned, it provides a basic level of DDoS protection right out of the gate. The server level also provides us with firewall capabilities, so it'll block all client connections other than those IP address specified in the rules. It gives us Azure authentication, so that's handled by Azure Active Directory. Users will log in, and you'll use an organization account identity, and then role-based access control will be applied to the dataset. We can take advantage of server administrator roles, so only people who need to administer the server actually get the role and the privileges they can do to do that job. And finally, server-side encryption is important because we want our data encrypted at rest in the Azure cloud. At the data model level, user roles, row level, and object level security ensure our data is safe and gets seen by only those who are meant to see it. Analysis Services uses role-based authorization that grants access to server and model database operations, objects, and data. So if you need access to that data to do your job, then your role-based authorization will grant you access. Row-level security. So tabular models at all compatibility levels support row-level security. It's configured in the model using a DAX expression that defines the rows in a table and any rows in any direction of a related table that user can query. Row filters using DAX expressions are defined for the read and process permissions. So we can actually drill down and do row level security and object level security. So tabular models at the 1400 compatibility level support object level security, which includes table level security and column level security. So Azure Analysis Services is very much secure at the server level and at the data model level. Service principals. Service principals are also something that we can take advantage of. Service principals are an Azure Active Directory application resource that we create to perform unattended resource and service level operation. We can also take advantage of Azure governance. So Azure Analysis Service is governed by the Microsoft Online Services team and the Microsoft Privacy Statement. And finally, what tools can we use to interact with Azure Analysis Service? Use the tools that you already know. So for object model and scripting, we can take advantage of tabular models that are very quick to deploy and very easy to customize. These can be tabular object model, TOM. TOM is exposed in JSON through the tabular model scripting language and the AMO data definition language. SQL Server Management Studio. Manage our servers and model databases by using the SQL Server Management Studio. connect to servers in the cloud, run our scripts right from the query window, and get a full insight and overview of our SQL servers and databases. We have support for open source tools as well. There's a vibrant community of developers who create tools that we can use with Azure analysis services. So that's great to go in and investigate. Maybe there's something already made that you don't need to make yourself. Visual Studio, so we can develop and deploy models with Visual Studio with analysis services projects. And finally, PowerShell. So server resource management tasks like creating server resources, suspending or resuming server operations, or changing the service level tier use Azure PowerShell commandlet. So there's a lot of tools, many that we're already familiar with, that we can use to interact with Azure analysis services. Now let's discuss Azure HDInsight. Azure HDInsight is a managed, full-spectrum open-source analytics service which provides easy, fast, and cost-effective ways to process massive amounts of data. You can use the most popular open-source frameworks such as Hadoop, Spark, Hive, LLAP, Kafka, Storm, R, and more. With these frameworks, you can enable a broad range of scenarios such as extract, transform, and load, data warehousing, machine learning, and IoT. So what is big data? Big data is collected in escalating volumes at high velocities and in a greater variety of formats than ever before. So we're pulling in a lot of data very fast in a lot of different formats. It's great for historical data, so it could be stored data from in the past, or it could be real-time data, streaming data that we're using in real time so we can get up-to-date insight on our real-time data. Let's look at some of the benefits of Azure HDInsight. First of all, it's cloud native. So Azure HDInsight enables you to create optimized clusters for Hadoop, Spark, LLAP, Kafka, Storm, HBase, and machine learning services on Azure. It has great extensibility, so we can extend the HDInsight clusters with installed components like Hue and Presto and so on by using script actions, by adding edge nodes, or by integrating with other big data certified applications. It also has global availability, so HDInsight is available in more regions than any other big data analytics offering. Azure HDInsight is also available in Azure Government, China, and Germany, which allows you to meet your enterprise needs in key sovereign areas. Another benefit is that it's low cost and scalable, so we can scale our workloads up or down. This helps us reduce our costs by creating clusters on demand and paying only for what we use. We have monitoring available, so HDInsight integrates with Azure Monitor Logs to provide a single interface with which you can monitor all your clusters. It allows for increased productivity. It gives you these rich productivity tools for Hadoop and Spark that'll work with your preferred development environments. These development environments can be Visual Studio, Eclipse, and IntelliJ for Scala, Python, R, Java, and .NET support. And finally, it's secure and compliant. HDInsight enables us to protect our enterprise data assets with Azure Virtual Network, encryption, and integration with Azure Active Directory. So as you can see, there are a lot of benefits of using the Azure HDInsight. So using Azure HDInsight, what are some scenarios that we can use? We can use it in a variety of scenarios in big data processing. First of these can be batch processing. So extract, transform, and load is a process where unstructured or structured data is extracted from a heterogeneous data source. It's then transformed into a structured format and loaded into a data store. You can use that transformed data for data science or data warehousing. Speaking of data science, it's another usage for HDInsight. We can use HDInsight to build applications that extract critical insights from our data. You can also use Azure Machine Learning on top of that. to predict future trends for your business. We can also use it for data warehousing to perform interactive queries at petabyte scales over structured or unstructured data. We can use it to extend our existing on-premises big data infrastructure to Azure to leverage the advanced analytics capabilities of the cloud, so we're creating a hybrid environment. And we can also use it for the Internet of Things. So we can process streaming data that's received in real time from thousands of different devices that are used in the IoT world today. What are some of the Azure HDInsight cluster types? We can use Apache Hadoop, a framework that uses HDFS, Yarn resource management, and a simple MapReduce programming model to process and analyze batch data in parallel. We have Apache Spark, which is an open source parallel processing framework that supports in-memory processing to boost the performance of big data analysis applications. We have Apache HBase, which is a NoSQL database built on Hadoop that provides random access and strong consistency for large amounts of unstructured and semi-structured data. We have machine learning services, so a server for hosting and managing parallel distributed R processes, provides data scientists, statisticians, and programmers with on-demand access to scalable, distributed methods of analytics on HDInsight. Apache Storm is a distributed real-time computation system for processing large streams of data really fast. Another cluster type is the Apache Interactive Query. That's in-memory caching for interactive and faster Hive queries. We can take advantage of Apache Kafka, which is an open source platform that's used for building streaming data pipelines and applications. And it also provides message queue functionality that allows us to publish and subscribe to data streams. Microsoft has designed Azure HDInsight based on Hortonworks Data Platform, or HDP. HDP is an open source framework which is developed based on Apache Hadoop, Apache Spark, and Apache Hot. The features and tools provided by HDP help businesses to gain actionable insights by analyzing both structured and unstructured data. The open source framework supports distributed data storage and facilities processing of large data sets. It also takes into account open source frameworks such as LLIP, Azure Kafka, Storm, HBase, and R programming. So it's a lot of open source frameworks that we can take advantage inside of Azure HDInsight. HDInsight clusters, including Spark, HBase, Kafka, Hadoop, and others, support a lot of different programming languages. Some programming languages aren't installed by default. For libraries, modules, or packages that aren't installed by default, you can use a script action to install that component. So our default programming language support is Java, Python, .NET, and Go. Many languages other than Java can run on a Java virtual machine as well. So if we run some of these languages, we might have to install additional components on the cluster. The following JVM-based languages are supported on HDInsight clusters. That would be Clojure, Python, Python for Java, and Scala. And finally, Hadoop-specific languages. So HDInsight clusters support the following languages that are specific to the Hadoop technology stack. That's Pig Latin for Pig Jobs, and HiveQL for Hive Jobs, and Spark SQL. So there's a lot of different programming languages that we can take advantage of depending on what you're comfortable with. You can use HDInsight development tools, including IntelliJ, Eclipse, Visual Studio Code, and Visual Studio to author and submit our HDInsight data query jobs. We can take advantage of the Azure Toolkit for IntelliJ 10, the Azure Toolkit for Eclipse 6, the Azure HDInsight tools for Visual Studio Code 13, and Azure Data Lake tools for Visual Studio 9. Familiar business intelligence tools retrieve, analyze, and report data that is integrated with HDInsight by either using the Power Query add-in or the Microsoft Hive ODBC driver. So we can connect Excel to an Apache Hadoop with Power Query, or we can connect Excel to Apache Hadoop with the Microsoft Hive ODBC driver. Both of these require Microsoft Windows. In-region data residency. So Spark, Hadoop, LLAP, Storm, and ML Service do not store customer data. They automatically satisfy in-region data residency requirements, including those specified in the Trust Center. Kafka and HBase do store customer data. This data is automatically stored by Kafka and HBase in a single region. So this service satisfies in-region data residency requirements. So if you have any data that needs to be in part of one region, we have to take mind of that when we're setting it up. So Kafka and HBase do store customer data, but it's stored in a single region. So that satisfies the in-region data residency requirement. And like we mentioned, Spark, Hadoop, LLAP, Storm, and ML Service don't store customer data, so they automatically satisfy the in-region data residency requirement. Now let's discuss the Distributed Data Engineering Toolkit, otherwise known as AZTK. The Azure Distributed Data Engineering Toolkit is a tool for provisioning on-demand Spark on your Docker clusters. AZTK is not an Azure service. Rather, it's a client-sided tool with a command line interface and a Python SDK interface that's built on Azure Batch. This option gives you the most control over the infrastructure when deploying a Spark cluster. It's considered a client-side tool, so it's not a server-side, it's not installed on the server, it's installed on the client side for you to use. You can use the command line interface and the Python SDK interface. And like we mentioned, it's built on Azure Batch. And you have the ability to bring your own Docker image, which makes setup simple and reproducible. The Azure Distributed Data Engineering Toolkit is free to use. You only pay for the cores you consume. Because it's built on Azure Batch, it has the ability to provision low priority VMs, letting you run your Spark jobs at an 80% discount. You can also take advantage of the mixed mode cluster, which gives you the option of Azure Blob storage and Azure Data Lake. So let's look at how to create a Spark cluster using the Azure Distributed Data Engineering Toolkit. Once we have the Azure Distributed Data Engineering Toolkit installed, we can start by creating a Spark cluster with a simple command line interface, AZTK, Spark Cluster Create. We have to specify some variables such as ID, so that would be your Spark cluster ID, your size, the number of nodes, and your VM size. Once your Spark cluster is ready, now's the time to submit some jobs against your cluster with the standard AZTK Spark Cluster Commit with the AZTK Spark Cluster Submit command. Again, we have to specify our Spark cluster ID. We have to give the name of the Spark job, and then we specify any options, like any app jars or any Python files that we may need, and also specify any app parameters that we want to pass into the application when the job goes through. The Azure Distributed Data Engineering Toolkit also supports interactive mode. So you're going to want to work interactively with your Spark cluster, and the Azure Distributed Data Engineering Toolkit supports working interactively by using the AZTK Spark Cluster SSH command, and you pass in your Spark cluster ID. By default, Azure port forwards the Spark Web UI to localhost 8080, Jupyter to localhost 8888, but these can both be changed if you configure the Thunderbolt ssh.yaml file. So how do we manage our Spark clusters in the Azure Distributed Data Engineering Toolkit? Some commands that we can do to manage our Spark cluster. To get a summary, we can use the AZTK Spark Cluster Get and pass in your Spark Cluster ID. We can delete a cluster by using the AZTK Spark Cluster Delete and passing in the ID as well. So there's a lot of ways to manage that Spark cluster and to use it interactively as well. So again, it's not Azure service, it's a client-side toolkit for you to use to interact with your Spark clusters on Docker images. So in this course, we've examined the components of a modern data warehouse. We did this by exploring modern data warehouse architecture, Azure Data Factory, Data Lake, and Databricks, Azure Analysis Service, HDInsight, and the Distributed Data Engineering Toolkit. In our next course, we'll move on to examine data ingestion and processing on Azure.